Hi everyone, welcome back to our sessions on software testing. Today we are gonna continue with our discussions, and we'll continue with the topic on test generation strategies. So, what is test generation strategy and what it is? We'll more details on it as well. We'll be also looking into some of the other topics. But before getting started, I would request you everyone to kindly like the video and subscribe to this entire channel. That will keep me motivated for making more videos for you guys. Okay, so let's get started. So, test generation strategies. Now, one of the key tasks in any of the software test activity is to generate the test cases, right? The program under the test is executed against the test cases that we will be having so that we can determine whether or not it conforms to the requirements that have been posted, right? Exactly. Now, the question how to generate test cases is normally we'll see where as we go ahead, but any form of test generation, right? It uses a kind of a source document. It will require a document which it will be referring for generation, right, of the test cases. Now, in the most informal of the test methods, the source document will reside in the mind of the tester who will try to generate these tests based on the knowledge of the requirements. Right now, in some organizations, the tests are generated using a mix of formal as well as informal methods. They are often directly from the requirements documents that is provided as a or that serves as a source. Right now, at the same time, in some of the other test processes, requirements will serve as a source for the development of some of the models that have been used for the test generation. Okay, so can we have like a quick summarization or diagram that will basically try to tell you about all the different strategies that could be used for test generation? So if you can see this now here, the top row, if you see, it will try to capture some of the techniques that are applied directly to these requirements. Now, these may be some informal techniques that can assign values to the input variables. They might not use any rigorous or any formal models. And there could also be techniques that identify the input variables that would be capturing the relationship amongst the variables and use some formal techniques that could be used for the test generation, like for example, the random test generation and cause effect graphing type of methods. Right? Now, most of these test generation strategies will try to use requirements as the base, right, directly or indirectly, so that it is able to generate the test. However, some of the random testing techniques, it also focuses on some of the specific behavioral characteristics of the program. For example, uh, you know, if there is a crash, then it might not necessarily derive the test cases from the requirements, but it is something that is almost, you can say that these are some of the behavioral characteristics that is implied. So it is understood that way. Okay. Now, coming back to what are the different types of software testing strategies that we can have and what are the things, right? So we'll spend some time, in understanding these. We'll try to spend and understand some of these aspects as well now. So when it comes to this type of testing, what types of testing are performed in normally in an organization? If I have to ask you in this way, so normally the kind of answer we would be getting is some of the familiar keywords, right? For example, you might some people will say black box testing, right? Some people will say that it is reliability testing, right? Reliability testing, or some of the other methods that could be available, right? So. Uh, One thing that we'll have to understand is there exists a number of these terms that will try to specify some one or more of these testing. Now, what we'll say is we'll say all of these terms as we'll denote all these terms with a specific term. Let's say we say it as X testing. Okay. Now, what we'll say is we'll try to have a kind of a framework for these classifications of these testing techniques. And then we can use this framework to classify the variety of these testing techniques by giving some specific meaning to the X as part of the X test. Okay. Now, this framework consists of some set of different classifiers that will serve to classify the testing techniques. Okay. So we can have, under different categories, under different methods that we can say, and we say that, let's say, on the very high level, we can say with respect to dynamic testing and static testing, right? So that gives a first level understanding of the data. And then what we'll do is, as we move ahead, we'll see some of the methods, right? So dynamic testing normally, when we know, right, what is dynamic testing, it will be, which will also require that execution of the program is understand is being done in a dynamical manner, right? So it keeps on changing as per, the scenarios that might be happening. Right? Now, there are different classifiers that you can see here, which is C1, C2, C3, C4. So these are basically the four classifiers that we have identified that we want to classify, how do we classify the set of features, with respect to the set of testing techniques that we can have, right? Now, some of these features will include the source of the test generation, like questions that will define a goal, a phase of life cycle, or an artifact for that matter, right? So what are these? So we have C1, which is the source of tested generation. We have C2, which is more of the life cycle phase in which the testing will take place. We have C3, which will speak about the goal of the specific testing activity. We have C4, which specifies about the characteristics of the artifact and the test. And we can also say a C5, let's say, which will be with respect to the test process. Okay, so these are the different classifiers that we can say that will basically state the which phase of the life cycle that we have. Now, if you see each of these classifier, what we'll try to do is we'll try to specify the mapping and we'll try to see some of the examples under each of them, like which are the specific categories that falls under this, right? So if you see this, this is more of a table that we're gonna give. Like for example, if you see black box, right? Now, black box testing is used almost in all of the goal-directed testings. Like, so you have some specific goals that you want to have. So definitely you will be see, whether it's ad hoc testing, whether it's boundary value analysis, you have category partitions, you have classification trees, you have cause effect graphs, you have equivalence partitioning, you have partition testing, you have predicate testing, you have random testing, right? So all these are the different goal-driven testing that gets falls under the black box testing, right? So at the same time, these test techniques which are falling under C1 are more generic, right? So each of these technique under the C1 is basically potentially applicable to meet the, uh, you know, kind of the requirements that is being there or the goals that has been specified in C3, right? So if you see, so what is the artifact? So how we have done is we have tried to, provide it with respect to the classifier, right? So we'll spend some time in understanding each of the C1, C2, C3, C4. Now, within C1, the first thing that we have is, or we can see is with respect to black box testing. Okay. Now, as you know, test generation is an essential part of testing, right? And it is as we have testing, just as it is an essential, very, very important component, right? And there could be different varieties of ways that would be used for generating the test, right? Now, the test could be generated from informal or formal requirements that would be there, or, it could be with the aid or, with respect to some of the codes that would be available in the test. Now, some such type of testing or such form of testing is also called as black box testing. Now, when these requirements are informally being specified or how we can start using these ad hoc techniques or heuristics like that could be used for equivalence partitioning or boundary value analysis kind of things, right? At the same time, we can also have like model based or specification based testing, right? Now if you see model based or specification based testing methods, normally, these kind of methods will occur when these requirements are being formally being very specified. Okay, like for example, you have one or more mathematical graphical notations or state charts, or you have like even sequence graphs or the tests are generated using some of the formal specifications, right? So this also falls under the category or under a subset of, black box testing. It is also kind of a form of black box testing, right? And there are a variety of techniques that could be used for generating the test for black box testing and model-based testing. So we'll also look into some of those as we move ahead, right? Now, the next thing that we have is based on what is white box testing. Okay. Now, white box testing is mostly with respect to refers to the test activity wherein the code will be used in the generation of these testing activities, or let's say for example assessment of test cases, right? Now it is quite rare and almost impossible to use white box testing in an complete isolation, right? So as a test case, the test case might consist of both inputs and expected outputs, so one might use some of these requirements to generate these test cases, right? So the code is used like an additional artifact in the generation process. However, there could be techniques for generating the test exclusively from the code, and there could be some corresponding expected output from the requirements. Okay. So tools are available to generate these tests to distinguish, like for example, we can take, let's say for example, we want to distinguish all the, anomalies which are there in a program under the test, right? And we want to generate the test that basically will tell the program to give a specific output that we have. So in this case, what will happen is someone is claiming that they are using white box testing. It is reasonable that we can conclude that they are using some forms of both the black box and the white box testing, right? Now, in white box testing, the code is generally used to enhance the quality of the test. The code itself is trying to ascertain the goodness of the test. Okay, so this is something with respect to white box testing, and if you see, normally the code could be used directly or indirectly in the white box testing purpose perspective. So we can have more of a direct method or an indirect method, right? So we can have both of a direct or an indirect method. Now, in the direct case, what will happen? The tool or the human tester, they will basically try to examine the code and will try to focus on the current part that needs to be covered. Now, the test could be generated to cover this part. Whereas in the indirect kind of a case, the tests are generated using some of the black box techniques, right? They would be assessed against some code-based coverage criteria. There could be some additional tests that are being generated to cover the uncovered partitions, portions of the code that could be there. We need to analyze which parts of the code could be feasible, or there could be control flow, there could be data flow, there could be mutating testing that could be used for direct as well as indirect code-based generation methods also, right? At the same time, when there could be another method with respect to the component interface aspect, which is on interface testing. Okay. Now, what happens in interface testing? In an interface testing, the tests are often generated using a components interface. Okay. Now, the interface itself forms a part of the components requirements, right? And hence, this form of testing is also very gets categorized under the black box testing method. However, the focus on this is on the interface that will basically help us to consider the interface testing, which the interfaces is happening. There could be also techniques that could be used, such as pairwise testing, interface mutation, that could be used for generating the test from a component's interface specification. Now, in a pairwise testing, the set of values for each of these input is obtained from the component's requirement, right? Now, in an interface mutation, the interface itself, such as the function coded, could be there, like say for a user programming language like C, and there is a function that has been coded. Now, this can basically serve to extract the information that might be needed to perform some of these interface mutation. Okay. Now, while pairwise testing is clearly a kind of a black box testing technique, interface mutation is more of a white box technique, right? So it might be focusing on the interface related elements of the component under test. Now, ad hoc testing is not to be confused with random testing, right? The reason is in ad hoc testing, a tester is generating the test from the requirements, but without the use of any systematic method. Whereas in random testing, what happens is we use a systematic method. So what we are seeing ad hoc testing, and we also are seeing what is right? So now random testing is using a systematic method to generate this test. Right now, the generation of this test using random testing will also require modeling the input space and then sampling the data from the input space, right, randomly. Now, what happens is in summary, if you have to summarize, black box testing and white box testing are the two most fundamental test techniques, right? They form the foundations of the software testing, right? Now, test generation and assessment techniques are at the foundation of the software testing. All the remaining test techniques that have been classified by C2 to C4 will fall in either the black box or the white box. The next type of classifier that we have is the C2, which is the life cycle phase. Now, what happens here is the testing activities takes place throughout the software lifecycle. Now, each of these artifacts produced is often subject to testing at different levels of rigor and using different testing techniques. Testing is often categorized based on the phase in which it occurs, right? So there could be a table that would list various types of testing depending on the phase in which the activity occurs. The programmers might write the code during the early coding phase. They test their code before it is integrated with other system components, right? Now, this type of testing is also referred to as unit testing. When the units are integrated and the large component or subsystem is formed, then in that case, one does the integration testing also of the subsystem that has been taken. And eventually, what will happen is when the entire system has been built, its testing is also referred to as what we also called as system testing, right? Now, the test cases mentioned that we have mentioned will try to differ in with respect to the timing and the focus, right? So in unit testing, a programmer is focusing on the unit or the small component that has been developed. Now, here, as part of the unit testing, the goal is basically to ensure that the unit functions correctly with isolation. Okay. Now, in integration testing, what we'll try to do, the goal would be to ensure that the collection of the components functions is as it is being desired, it is trying to function. And integration errors are normally often discovered at this current stage with respect to integration testing. Now, the goal of system testing, what is the goal of system testing? It would be to ensure that all the desired functionality is in the system and it works as per the requirements, right? Now, the test has been designed during unit testing, right? They are not likely to be used during integration and system testing. Similarly, the tests that have been designed for integration testing might not be useful for system testing, right? So often, a carefully selected set of customers are normally being asked to test the system before release. So this type of testing is also referred to as a what we know as beta testing. So you might have heard about beta testing a lot of times when some organizations are bringing out with some software and all, right? So they do a lot of the beta testing. So that is basically they will try to ask a set of selected set of customers that you kindly test it before we want to release it, right? So in this case, in the, let's say for example, in case there is a contract software and the customer who has basically provided a contract for the development, they will also try to do what we also know as acceptability testing, right? So whether they want to go and make the final decision. So before that, whether they want to purchase it or not, they would like to do what is also called as an acceptability test. So let me just write it down for you. Right? So acceptability testing. Now, often a carefully set of customers that we say is also the beta testing, similar to that, the errors that has been reported by the users often lead to what is could be some of the additional testing and the debugging. Now, oftentimes, what happens, the changes that have been made to an application are much smaller in size when compared to the entire application, right? So that definitely there could be a need for a complete system test, right? Now, in such situations, one is performing a regression kind of a testing, right? So the whole goal of a regression testing is to ensure that the modified system functions as per the modifications or the specifications that have been provided. Okay. Now, regression testing may be performed using a subset of the entire set of test cases, right? So we don't go ahead and rerun the entire test cases, but we take only a subset of the entire test of test cases, and for that could be done for doing the system testing. Now, test cases selected for the regression testing include those that has been designed to test them, modified code, and any other code that might be affected by the modifications. Now, it is important to note that all the black box and white box testing techniques, right, are applicable during each life cycle phase when the code is being tested. Right. So, for example, one could use pairwise testing technique to generate the test for the integration testing. Right. So, one could also use any white box testing techniques such as, like, for example, test assessment or enhancement during regression testing as well. So, it keeps on. You will you have to keep on using it, yeah, interchangeably. Now, going ahead, what we have is the next type of classifier, that is C3, which is on goal-directed testing. Okay. Now, what is goal-directed testing? Now, goal-directed testing leads to a large number of terms that we might have in software testing, right? Now, here, if you see in this table, it lists a kind of sample goals that are commonly being used in practice and the names of the corresponding test techniques that might be used, right? So there exists a variety of goals, and finding any hidden errors is normally the primary goal of testing. Whereas goal-oriented testing looks for some specific types of errors or some specific types of failures, right? So the goal of, like, for example, if we take vulnerability testing over here, now the goal of vulnerability testing would be to detect if there is any way in which the system under the test can be penetrated by unauthorized users, right? So that's a vulnerability. Now, supposedly there is an organization, and this organization has set up some security policies and they have taken some security measures, right? So then we also have what is also called as penetration testing. Now, what is penetration testing? The penetration testing will try to aim at evaluating how good the policies and the measures are there that will help you in avoiding the penetration, right? Now, again, both black box and white box techniques could be used for the generation evaluation of tests, right? So that would be applicable for the penetration testing as well. And many organizations also, what happens, penetration and other forms of security testing remains or gets done on an ad hoc basis, right? So that is something. Now, another type of testing that you will see as part of this would be the robustness testing. Robustness testing refers to the task of testing an application for robustness against some of the unintended inputs. Now, how it differs from functional testing is that the tests for robustness are normally derived from outside the valid or the expected input state, whereas when it comes to functional testing, it is with respect to derived from a valid functional input space. Okay, now as an example of robust testing, supposedly there is an application is required to perform a function for all the values which are x greater than equal to 0, right? Now, then there is no specification of what the application must do when the values are less than 0, right? So in this case, robustness testing would try to require that the application be tested against a test where, also the x values which are less than 0, right? As the requirements is not specifying the behavior outside the values input space, right? A clear understanding of what the robustness is mean is required or it's needed for each of the applications. Now, in some of the applications, robustness might simply mean that the application displays an error message and is exiting, right? In some of the other spaces, it might mean that the application brings the aircraft to a safe landing, right? So there could be different connotations or different interpretations of this thing. The other type of testing that we have is also on the stress testing aspect, right? So what is stress testing? In stress testing, one is trying to check for the behavior of the application under applying certain kind of stress, right? So, for example, how it's handling the overflow of the data storage, right? So, for example, the buffers that might be there. So, can it be checked with respect to stress testing to check, in those kind of situations, what happens? Now, web applications can be tested using by applying a stress testing method by stressing them with a large number and a variety of different types of requests, right? So the whole goal of this kind of a testing is to find out if the application is continuing to function correctly under stress or it is basically failing to perform. Now, stress test for an application for it will try to test how the application is behaving under stress under different types or large number of inputs or the request that is coming in. Right? Now, once any person or a tester will try to need to quantify the stress, with respect to the context of the application, right? So, for example, if there is a web service that could be stressed by sending it an unusually large number of requests, right? Now, the goal of such of the testing it would be to check if the application is continuing to function correctly and is performing the services at a desired rate, or it is not. Right? Now, stress testing is also trying to check an application for conformance to the functional requirements as well as the performance requirements when analyzed. Now, performance testing, the term performance testing refers to that phase of the testing where the application would be tested specifically with respect to performance requirements. Right? For example, a compiler might be tested to check if it meets the performance requirements, right? That has been stated in terms of the number of lines of codes that have been compiled per second, right? And there could often the performance requirements are stated with respect to the hardware or the software configurations, right? So, for example, an application might be required to process 1,000 billing transactions per minute on a specific processor, right? So, all those are different examples how we can basically try to check what is the performance of the application or the performance of the program, right? Now, when it comes to the other type of testing that we'll see is what is called as load testing, right? So now what is load testing? So as the name suggests, right? So it's basically trying to test or it tries to refer to that phase of the testing where the application would be loaded and how what are the different types of operations that the behavior of that application, right? So the goal here would be to determine if the application is continuing to perform as required under the various conditions or it is not, right? So for example, if there is a database server that could be loaded with requests from large number of simulated users, right? Now, while the server might work correctly when one or more of these users use it, it might basically fail in the other ways where the number of users might be exceeding a threshold, right? So that could be another example. Now, during load testing, one can determine whether or not the application is handling exceptions in an adequate manner. Like, for example, an application might maintain a dynamically allocated buffer to store the user ID, right? Now, the buffer size is increasing with a specific increase in the number of simultaneous users. There could be a situation when additional memory space is not available to add to the buffer. Now, a poorly designed or an incorrectly coded application might crash in such kind of situation. However, if there is a carefully designed and correctly coded application, it will basically handle the out of memory exception in a more graceful manner, such as, by announcing there could be a high load, there could be a message that could be shown that could basically help, right? So, in a sense, if load testing is being considered, it could be considered as yet another term which is similar to stress testing, right? However, load testing can be performed for ascertaining the application's performance as well as the correctness of the behavior. And it is a type of stress testing itself where the objective is to check for correctness with respect to the functional requirements under the test, right? So it is a form of performance testing where the objective is to assess the time it takes to perform certain operations under a range of given conditions, right? And load testing could also be considered with respect to another kind of testing, which is also called as robustness testing, right? So when it comes to robustness testing, the testing for the unspecified requirements, right? So there might not be any explicitly stated requirement related to let's say the maximum number of users the application would be able to handle or what the application must do when the number of users is exceeding a specific threshold, right? So in such kind of situations, load testing might allow the tester to determine the threshold beyond which the application under the test might fail to. Okay, so that is what the importance of load testing is. Now, there is another important aspect, or there is an important term, which we also call it as terminology overlap. Okay. Now, there is some overlap mostly with respect to the terminologies that would be useful. Like, for example, you have vulnerability testing. Now, vulnerability testing and it's a form of a security testing, right? So there is a kind of an overlap because of the terminology, right? Like similarly, testing for compatibility with business goals might also include the vulnerabilities, right? So normally what happens is such kind of overlaps are very much found or are found about in testing related terminologies, right? So The formal techniques for test generation and the adequacy assessment applies to all forms of goal-directed testing, whereas a lack of these examples might be there, which could basically help you, might be able to see that there might be overlap that might be there, and if these key terms based on the context of the scenarios, they would be used interchange. Okay. And the last type of classifier that we have is the C4, which is the artifacts and the test. Now, testers normally will say that we want to do X testing, whereas could be X corresponding to a specific artifact that could be there on the test, right? Right. So there could be a different ways or different list of testing techniques, right? That would be named after the artifact that is being tested. Now, if you can see and if you have a look at this table, if you can see during the design phase, let's say for example, let's say we want to in the design phase we might try to generate a design using some of kind of a notation. Now this design can be tested before it is been committed to code, right? So this kind of a testing is also called as design testing, right? So as part of this design testing, what we are trying to do is in the design phase we are trying to generate or try to test the design that has been generated, right? So if you see the classification of these techniques that has been shown over here and that has been listed, what are the specific characteristics that have been shown or that has been yeah been provided over, right? Now, if you see, there could be different types of, like, for example, we have object-oriented testing, right? So we have different types of object-oriented softwares which are available, right? So, like, for example, you have C++, right, or Java. Now, there could be variety of test generation and adequacy assessment techniques that can be falling under the black box and white box categories that we have seen. Now, these also gets applied to the testing of the object-oriented software or the OO software. So it is very much important to note that specialized black box and white box testing techniques are available for the specified specialized software. Now, for example, you have time automata, you have Net-based test generation techniques, right? They could be intended for the generation of the test for the real-time software, right? Now, batch processing applications normally will try to pose a very serious challenge when it comes to testing, right? Like for example, you have payroll processing software, or as the student recording processing, these kind of applications, right? So these are examples when you see a lot of batch processing. So these applications often you'll see that they will perform the same test set of tasks on large number of records, right? Let's say they keep on doing this on a specific batch of records, right? So using the notations that we might have for respect to equivalence partitioning or other requirements based on that, first and foremost thing that we will have to ensure is that each of these records needs to be processed correctly, right? Now, additionally, one must also test for the performance that is there under the heavy loading conditions. Now, this could be done using a load testing, right? Now, while testing a batch application, it is also important to include a for Oracle, let's say, for example, that will try to check the result of each of these tests.